In this video lecture, I am going to discuss about the primitive shortest job first scheduling algorithm, which is also called as shortest remaining time first scheduling CPU scheduling algorithm. It's when a running process is preempted, then such process are switched to the ready state. It means that when a process which is running or which is executing in the CPU is terminated or is preempted, that is forcibly terminated, then that process is kept in the ready state or in the ready queue. And among the available process that have short burst time, that is scheduled first. It means among the process which are available in the ready queue, the process which has the short burst time, that is given CPU for its execution. And the last point is, while a process is in a running state, it is preempted if and only if another process with a shorter burst time has arrived in the ready state. It means when one process is executing in the CPU, then it is preempted if and only if the other process which has arrived has the shorter burst time than the previous process which is executing in the CPU. Means the the arrived process which has shorter burst time will be given CPU for its execution, and the process which was previously executing in the CPU will be placed in the ready state. Then examples of primitive shortest job first scheduling. What does it say? These are the processes, and these are its arrival time. And burst time is also given. The actual burst time is 5, 3, 3, 1 for process P1, P2, P3, P4. And these are its arrival time. What we have to do, we have to calculate turnaround time and the waiting time. So for this, we have to first prepare a Gantt chart. So how we will prepare Gantt chart? First we will see arrival time of process, which process has arrived first. P1 has arrived first. So P1 will be executed for one time unit, because at time 1 unit process P2 has arrived. So process P1 has executed for one time unit. Now how much time it has left? 5 minus 1, that is 4. Now process P2 has arrived, so it will also be executed for one time unit. So 1 plus 1, 2. At 2 time unit process P3 has arrived. But there are three processes in the ready queue, P1, P2 and P3, whose burst times are 4, 2 and 3. So which one is minimum? P2 has the minimum burst time, so 2. So it will be executed till 2 time unit. So 2 plus 2, 4. Now again at 4 time unit process P4 has arrived in the ready queue. So what is its burst time? 1. So it is the minimum, so it will be executed till 1 time unit P4. So 4 plus 1, 5. Now at 5 time unit all the processes are in the ready queue, but process P4 has finished its execution. And which process has left? P2 has also finished its execution. So only P1 and P3 are there in the ready queue. So P3 will be executed because it has the minimum burst time of 3 and P1 has a burst time of 4. So 5 plus 3, 8. So till 8 time unit P3 will be executed. So now which process left? P1. What is its burst time? 4. So 8 plus 4, 12. Till 12 time unit P1 will be executed. Now we have to calculate the turnaround time. What is the formula for calculating the turnaround time? Completion time minus arrival time. So what is the completion time of process P1? 12. So arrival time is 0. So 12 minus 0 is 12. P2 completion time 4 and arrival time 1. 4 minus 1, 3. And P3 completion time 8. Arrival time 2. 8 minus 2, 6. And P4 completion time 5 and arrival time 4. So 5 minus 4, 1. Now we have to calculate the average turnaround time, which is the summation of this divided by the number of process, which is coming 22 by 4, 5.5 seconds. Now we have to calculate the waiting time. What is the formula for waiting time? Turnaround time minus burst time. So what is the turnaround time we got for each process? For process P1 we got 12 as the turnaround time and its burst time is 5. So 12 minus 5 is 7. Then process P2 turnaround time is 3 and its arrival time, burst time is also 3. So 3 minus 3, it is 0. And for process P3 turnaround time is 6 and burst time is 3. So 6 minus 3 is 3. and for process P4 both turnaround time is 1 and burst time is 1. So turnaround time minus burst time, 1 minus 1 0. So what will be the average waiting time? Average waiting time will be 7 plus 0 plus 3 plus 0, summation of all this divided by the number of process, which is 4, 10 by 4, which is coming 2.5 second. Thank you.